Welcome to my channel. I am going to actually make mathematics easy for you as ABC. Okay. First of all, today we're going to discuss rational numbers. What is a rational number? A number which can be written in the form A over B, where A and B represents integers and B is not equal to 0. Now, just assume A is equal to 8. B cannot be equal to 0 because 8 divided by 0, which we would call infinity. All you got to remember about a rational number, in other words, whenever you see the word rational number, just think of one thing only: division. This is division. Proper fractions. What you got to know about this is numerator is less than the denominator. The numerator will be above, the denominator will be at the bottom. Let me give you something as an example. Let's take 2 over 3. Can you see that the numerator 2 is less than 3? So this here is a proper fraction. Another example would be 4 over 5. That's another example of a proper fraction. Take 3 over 8. This is a proper fraction. Why? Because the numerator is less than the denominator. Improper fractions. Denominator is less than the numerator. Let's take an example. 8 over 3. Right, let's see it. Denominator is 3. It's less than the numerator, which is 8. Let's take another example. 9 over 2. Right. What you have to understand about is that an improper fraction can be converted to a mixed number. Let's take another example. 74 over 24. What I can say, 24 can go into 74 how many times? 3 times. 3 times 24 is 72. Remainder 2 over 24. Now, when we come to fractions, we will have to rewrite this fraction in its simplest form. So what I'm going to do, I'm going to say that's equal to 3 wholes. The 2 I am going to divide it by 2. 2 divided by 2, and I'm going to take the 24. 24 divided by 2, that gives me 3, and 2 divided by 2 is 1. 24 divided by 2 is 12. Mixed numbers. Let's take an improper fraction, 8 over 3. What does this mean is 8 divided by 3. 3 can go into 8 2 times. 3 times 2 is 6. I have a remainder of 2 all over the 3. Let's take a look at another example. 4 divided by 3. What you can see is that 3 can go into 4 one time. We have a remainder of 1 all over 3. What do you notice? A mixed number contains a whole number and a fraction. Mixed numbers to improper fractions. What you're going to note here is you're going to take the denominator times the whole number plus numerator, and then we're going to divide it by denominator. Okay, in other words, basically what we're saying is denominator times the whole number plus numerator divided by the denominator. Now let's take an example. 1 and 2/3. This is basically equal to, what is my denominator? It's 3. 3 times, what is my whole number? 1. So it's 3 times 1. And then I'm going to add the numerator, which is 2. Then I am going to divide by the denominator, which is 3. It's equal to 3 times 1 is 3 plus 2 is equal to 5 over 3. Simplifying and reducing fractions. What we're going to do here is going to divide numerator and the denominator by the same number. Now let's take an example. 4 over 12. What I will do in this case here, I will say 4 divided by 4. 12 divided by 4. Okay, 4 divided by 4 gives me 1. 12 divided by 4 gives me 3. My answer is 1/3, but the second step can be skipped. You don't have to put the second step. I'm just showing you exactly what we are doing. So it's saying 4 over 12 would equal to 4 divided by 4, which gives us 1, and 12 divided by 4 will give us 3. Let's take it another example, 24 over 36. What I would say is, I would divide by 12 because 12 goes into 24 and 12 goes into 36 exactly. So 24 divided by 12 all over 36 divided by 12. This gives me 24 divided by 12 gives me 2 over 3. But let's take another student who doesn't understand this, who is having difficulty multiplying and dividing. Now, here's a rule. What you would do, you would divide by its prime. Divide by its prime. Now, let's say 24 over 36. So I would say, hey, 2 goes into this thing. Okay, let's do it easy. 24 divided by 2, 36 divided by 2. This gives me 12 over 18. Now I'll say, hey, 2 can go into it, no problem. 12 divided by 2, 18 divided by 2, that gives you 6 over 9. Now I'll say, hey, 2 can't go into this thing here because these are odd numbers. So what's the next number? Let's try 3 because it's a prime. 6 divided by 3, 9 divided by 3, and 6 divided by 3 is 2, 9 divided by 3 is 3. Now what I can say, this is 2/3. Can you see the difference? If we know our timetables, we will not have a problem. But if we don't know, this is what we would have to do. Equivalent fractions. The rule here is multiply numerator and denominator by the same number. Let's assume if I got 2 over 3, I want to write this as a denominator of 9. So I would say, what do I do here? From 3 to 9, what did I do? I said 3 times 3 gives me 9. So whatever I do at the bottom, I must do the same on the top. 2 times 3. This will give me 6 over 9. Let's take another example. 3/4 would equal to something over 100. From 4 to 100, what did I do? 4 times 25. So I must do the same on the numerator. 3 times 25, that would give me 75 over 100. Equivalent fractions. Here the rule will be divide numerator and the denominator by the same number. Let's take an example. 24 divided by 36. Now I want to write this as an equivalent fraction with a denominator of 3. So I'll say from 36 to 3. If I divide this by 12, I would have to divide the numerator by 12 also. So now I'll say 24 divided by 12 gives me 2 over 3. Now let's take in another example. Let's take 48 over 96. I want to write this as something over 8. So I would say 96 divided by 12 gives me 8. 48 divided by 12 will give me 4. Whatever you're dividing, you will always divide by the same number. Now, look at it another way. Let me explain to you is that, can you see here? Sometimes we have 36. Sometimes it's easier for a student to say, instead of saying 36 divided by 12, for the student it's easier to say 3, from 3 to 36, what did I do? I times it by 12. But I won't times it by 12, I'll have to divide by 12 on both sides. Same like in this case. Instead of saying 96, from 8 to 96, I can say 8 times 12 gives me 96. So, I'll say 96 divided by 12 and 48 divided by 12. Comparing fractions. There are two rules here. Number one, we'll find the LCM or LCD. Different countries would say it differently, but which means the same thing. The second rule is express one or both as equivalent fractions. 5 over 7 compared with 4 over 6. I'll find my LCM of 7 and 6, so it will be 7 times 6, which is equal to 42. Now, I'll have to write both of this fraction as equivalent fractions. So 5 over 7 would equal to something over 42. So 7 times 6 gives me 42, so 5 times 6 gives me 30 over 42. Now, the next step is, let me take the 4 over 6. 4 over 6 would equal to something over 42. So 6 times 7 gives me 42. 4 times 7 gives me 28 over 42. From this, because my denominators are the same, I can say that 30 is greater than 28. So 5 over 7 is greater than 4 over 6. The rule is to cross multiply, but always remember we start from the numerators. Right. So basically I would cross multiply. There's my cross. So what is 5 times 6? It gives me 30. And above. What is 4 times 7? 28. From this I can see that 5 over 7 is greater than 4 over 6. This is a much simpler method. Thanks for watching. Please click the like and subscribe button for me. I really appreciate that from you guys.